All right, let's start to explore the relationship between electron shells and charges. Remember, sodium chloride, table salt. The sodium has a +1 charge, the chloride has a -1 charge. That's actually why they get together. Positives and negatives attract. So why would something be positive and something be negative? And actually the key to that is in the periodic chart of the elements and the electron shells. So let's start with lithium. Lithium is element number 3, right? And so if it's element number 3, that means that it has 3 protons. It's going to start off with 3 electrons. So, here's the first shell, here's the second shell. So it's going to have 1, 2, now that's full, and here is 1 electron, the third one, in the second shell. Now remember that only the far right-hand column is truly happy. Those are the only elements that have completely full electron shells. They're called the noble gases. They're inert. They don't react. Everything else on here reacts and is going to do its best to fill those electron shells. So if we look here at lithium, lithium's not happy. Lithium has 1 in its outermost electron shell, and it needs 8 to have that full shell. Do you think it's easier to ditch 1 or steal 7? Go with the obvious. It's easier to ditch the 1. And lithium will do that. Lithium will ditch an electron. And now lithium looks like this. Lithium on the outside looks like a helium. Helium has 2 electrons in its outermost shell. It's full, and helium does not react. So check this out though. It's still lithium inside in its nucleus. It still has 3 protons. So what's going to happen? The 2 electrons, I ended up with a +1 charge. And look at what number 11 is. Number 11 is sodium. Sodium has a +1 charge. So the elements in column number 1 tend to have a +1 charge. They tend to have 1 more electron in their electron shell, so their outermost electron shell would have 1 electron, not happy, and it is easier to ditch. And sodium would have 2, 8, 1, that's number 11, sodium, right? So, 11, sorry. And it's going to ditch that and look like neon on the outside. And by ditching that outermost one, 2, 8, it's got 2 full electron shells. It's going to have 10 electrons and end up with a +1 charge. So that's why sodium and lithium and potassium have +1 charges. Well, then they're going to need to have a mate. They're going to need to have a negative charge to get together with to make it full and make it happy. And so let's check out fluorine. Fluorine's right here. Okay, so fluorine is element number 9. And that means, remember, the numbers mean how many protons you have. So 9 protons. So what's it look like? Okay, there's the little teeny nucleus. 2 in the first shell. And then 7. 1, 2, 3, 4, 5, 6, 7. Now remember, you're not happy unless your outermost shell is full. And so yeah, fluorine will steal one of those electrons that's kind of flinging around out in space and put it in there. Now check it out. It's got a full outermost shell. And it now on the outside looks like neon. Okay? But it's still fluorine on the inside, so it still has 9 protons, leading to a -1 charge. Now, the elements in column number 1 tend to have a -1 charge. The elements in column number 6 tend to have a -2, and I didn't really mention it before. Over here, the elements in column number 2 tend to have a +2. Because remember, beryllium has 2 sitting in that outermost shell. It's going to ditch them. It's easier to ditch 2 than to steal the 6, and so this is what creates the positives and negatives. And kind of the rule of thumb with ions, so positive or negative ions, these elements tend to be attracted to each other across the periodic chart of the elements. A +1 is going to be attracted to a -1, a +2 to a -2, and heck, even a +2 could have 2 -1s just so that it balances, so you go to a 0. Think of it like a bank account.